us to topic 6, radical expressions and expressions with rational exponents. So a rational number is anything that can be made into a fraction. So what we're dealing with here is exponents that are fractions. An exponent that's a fraction is really a radical expression. So let's go look at this. Exponent that has a fraction and can be written as a root of the base. So for example, if I have 4 and my exponent is 1/3, I can rewrite that as a cube root of the base 4. So in order to better understand this, it's important that we understand the key features. So when we talk about 145, most of you know that's the base. Okay, but we also call it the radicand. So the base is the radicand. Okay, then when we have a fraction exponent, our numerator will be the exponent that goes on the radicand. Okay, now the denominator is basically our root or our index. Okay, so I can take my power written this way, and I can rewrite it as a radical. So here I still have my base, but now it's called a radicand because it's inside my radical. This is still the exponent. That was the numerator of my fraction. And then here is my root, my index. So what sits right there inside that, you want to call it a check mark. That's the root. That's how many times something happened, how many times it was multiplied. When we look at this symbol, okay, most of us say, oh, that's a square root. No, it's a radical symbol. It can be a cube root. It can be a fourth root. It can be a fifth root. Right now it's a cube root because there's a 3 there. When you used to been seeing it, there's nothing there. There's no number there. That means that's a square root. There's technically a number 2. Okay, so what we can do is we can take a rational exponent and write it as a radical. I'm going to write my base inside. My numerator, which would be my exponent of that base. So that 3 becomes the exponent. Then my denominator is really my root, and that goes outside. I've now rewritten it. Some of you might be sitting there saying, well, why does it matter if we rewrite it? You'll see in a minute why we want to be able to rewrite it properly this way. Okay, so this one, I have 486. That's my base. That's my radicand. That goes inside first. My numerator is the exponent. My denominator is my index. That goes right there. I have now rewritten it as a radical. Pretty straightforward, right? Okay. So I've got my base. Go ahead. What would you do next? That's right. You take your exponent and you put it there. Okay. Where do you put the 3? I hope you all put it there. Okay. So take a second. It shouldn't take you too long to rewrite this one. Okay, most of you probably did this. Now, some of you probably took that numerator of 1 and wrote a 1. That's perfect. But I'm going to tell you something. I don't have that 1 there. If you have it, it's not wrong. You would not get it marked wrong. But then we take this 3 and we put it right there in the index. So it's the cube root of 125. Okay, now, why would I need to do that? Well, say you get this problem and it says to simplify. You don't have a calculator. So we have to know how to do this without a calculator. Well, step 1 is going to be to rewrite it, just like we did. So if we rewrite it, my radicand goes inside, my numerator is my exponent, and my denominator is my root. Step 2 is going to be to find the prime factors of the radicand. So in this example, it's 24. You might want to add to your notes, it means do a factor tree. So I'd write where it says find the prime factors, parentheses, do a factor tree of your base. Meaning, what times what gives me 24? Me, I chose 3 and 8. There's other ones. You could have picked 6 and 4. You could have picked 2 and 12. Doesn't matter. 3 is prime, so that branch is done. But 8 can be broken down to 2 and 4. 2 is prime, so that branch is done. But 4 can be broken down to 2 and 2. Okay? Why do we do this? Well, the index. So on this one, remember your index is the denominator. So in this one, it's a cube. It's going to determine how many matches make a group. So we need to make a group. That index is going to tell you how many you need. So in this one, my index is 3. So in order to make a group, I need 3 of something. Okay? So since my index is 3, I need numbers whose factor shows up 3 times. That's what I'm going to bring out. And you'll see what I mean by this in a minute. Okay? Any number that makes a full group will come out. What do you think I mean by come out? Well, take a look here. I have 2 times 2 times 2 times 3. But I have it there twice. Does anyone know why it's there twice? Okay. I had 24 squared. If we go back for a minute, do you notice how inside it says 24 squared, meaning I have 24 2 times? All I did was write this. I wrote 24 as its prime factors, but I wrote it twice because it's there twice. But what I like to do is create a separate row. So that top row is my first 24, and the bottom row is my next. Now we said I need 3. Okay, there's a group of 3. There's a group of 3. Not the number 3, but 3 of the same number. That is what's going to come out. Okay, so I'm going to bring out a 2 and then another 2. I'm not bringing out 6 2s. I just made a group of 2s. How many groups of 2 do I have? 2. Any number not in a full group stays inside. So now I've got a 3 and another 3 inside. Remember, I needed 3 of a type. So that's going to stay inside. My last step is to simplify. Well, what does that mean? It means multiply whatever you brought out and whatever's left inside. Okay? Again, I need everyone to understand this concept is pretty much brand new for everyone in this room. It might make more sense to others, but that's okay. We're going to go through some more examples and we'll do this. We'll have plenty of practice. So if you were given this and it said simplify, you're going to do the steps we just did. Now these 2 are a little easier, but that's okay. First, we want to rewrite it. Then we break 27 down. That's 3 times 3 times 3. Now look at my index. That means I need 3 in a group. Well, I've got a full group. So I'm going to bring it out. Now, was there anything left inside? No. So my radical's gone. And here's why. 27 is a perfect cube root. The cube root of 27 is 3. So there will be times where everything comes out, and that's okay. Okay. So square root of 12. I have 2 times 2 times 3. Now, some of you might be a little confused. There's no number here. So how many go in a group? Well, it's a square root. So when there's nothing written there, you want a group of 2. So the 2 is going to come out and the 3 is left behind. So when you have variables, it's the same exact steps, except for now, until you see a pattern, until you have this down, I would write out the variables. Okay, what does that mean? Well, we're still going to do our factor tree of 48. I chose to do 6 and 8, and then 2 and 3, so those branches are done. And then 2 and 4, and then 2 and 2. Okay, so I write out all of those. But I have 5 B's, so I write out 5 B's, just like that. So I've got all my factors written out, and I've got all my variables written out. So looking at my index is a 2. And a lot of you might be saying there's no root, there's no index. Yes, it is. In a radical, when there's no number written there, it's a 2. That means I need groups of 2. So I have a set of 2, 2. That's a group of 2 also. Remember, B is a number, we just don't know what it is right now. And then another group. So since they have a partner, I can bring them out. What am I bringing out? I brought out 2 2s and 2 B's. That 3 and the other B stay because I didn't have a partner. And I'm left with 4B squared times the square root of 3B. Okay, I'm going to do these two with you. So 54. If I broke 54 down, okay, that is 2 times 3 times 3 times 3. There are 7 ends. Look what I did. If you don't want to have a long line, you can stack things. That's okay. Now this is a square root, meaning I need partners. So I only see a partner pair there, but here I've got 3 partner pairs of ends. So when I bring it out, I'm going to have a 3. I'm going to have 3 ends. What's left inside was a 2, a 3, and another n. So this is a lot of attention to detail and making sure you're looking at what's left over. So you got to organize your work and you got to do every step. Last, we simplify. There's nothing in times by the 3, but I can rewrite the ends outside as n cubed. Then on the inside, 2 times 3 times n. Okay, so here's how I do this one. First, you're multiplying radicals. So you can do that. I would do 2 times 3, and then I'd put everything under one big radical. And don't worry, we're going to go in. There's another video. There's a whole day on this. But I wanted to touch on it. So here, I now have 7 times 14 times t squared. I'm then going to break down my 14. 7 times 2, and then write out all my t's. Still the same thing. I'm still going to make partner pairs because it's a square root. I have a group of 7s, and I have a group of t's. There's nothing else that has a partner. So the 7 comes out, and a t comes out. Remember, I still have the 2 and 3 from the original problem outside. That's going to get multiplied as well. So I have 42t times the square root of 2t. Okay? Just try these. Just go back and look at what we did. Okay, look what we did. You should have this detailed work. If you don't, pause now and copy it down. Try these on your own. You can do it. Okay, let's see how you did. If you break down the 80, okay, and you write out the 9's, 9m's I should say, look what I had to do. I had to go in another line because I'm trying to put 2 problems on one page, but that's fine. So it's a square root. We're just dealing with square roots right now. I had a group of 2s. I had 2 groups of 2s. and I had 4 groups of m's, but there was a negative m outside. So I have 1, 2, 3, 4, 5 m's. Okay. Did you get that? Okay. Let's try the next one. Remember, I put my numbers outside and everything under one big radical. Then I'm going to break things down because sometimes you might already see a pair, but I don't. So I'm going to break down 2, 3, 3, and then there's 4 a's. So what's going to come out is a 3 and 2 a's. So that I have 21a squared, square root of 2. So I'm not going to lie, this is probably one of the more challenging topics, and we're going to spend some more time in class. But comment below, what was hard? Was it hard once I introduced the variables? Was it hard from the start? One of the steps, did we not understand it? Are we struggling on a factor tree? Please comment below so that I understand. If you get it, click like.